Okay, we're here with Simon from Arm. Simon, tell us a little bit about Arm and about the conference today.
Okay, so Arm is an IP licensing company, and what we do is design components that other people put into their chips that ultimately end up in consumer devices such as mobile phones or handheld video recorders. We're a licensing company, so we don't actually manufacture anything, but what's really important is that we enable our customers to go and manufacture their chips. My part of the business is what we call the physical IP business, and what that is about creating very low-level building blocks that people need to map their designs into a layout that can be manufactured in a foundry. The event today is the Common Platform Technology Forum. Common Platform is the combination of IBM, Samsung and Global Foundries who've joined a partnership together to try and lower the cost of developing advanced technology. We've been working with those three companies for a number of years. Yesterday we announced an extension of our collaboration with IBM to work towards 14 nanometer technology. Now 14 nanometers is a very, very small transistor, and why that's important for these devices is that it enables us to build chips which consume very little power yet run at very high performance, and they're all characteristics that you want in your handheld battery powered device.
But of course, getting down to those really, really small sizes, it's not as easy as it sounds. I mean, I understand that there's a huge leap in the amount of challenges, for example, from going from 28 nanometers down to 20 and then below. I mean, can you tell us a little bit about how difficult it is to get to those really, really tiny sizes and low powers?
Well, each time we go to one of these new geometries, there's a whole new set of physical effects that come in to do with the fact that what you're building is really small. You're into multiple numbers of atoms of device size, and you're trying to draw the shapes using a wavelength of light that's an order of magnitude larger than the shape you're trying to draw. That introduces a whole load of complexities, and what happens in the R&D phase is that you try lots and lots of experiments to see what works, what doesn't work, what can be manufactured with high reliability and what can't. So this collaboration that we've been doing with IBM, with the Common Platforms, really important to start that experimental work very early in the cycle, so that as the technology matures, the ARM components that support that technology are all ready, they're all silicon proven, so one of our customers can start using them with as low risk as we can possibly achieve.
And we're talking about smartphones and smart devices coming up in the next few years that will be incredibly fast in terms of computing power, and we assume also incredibly long lasting in terms of battery life. What would you predict we'd be able to see in terms of battery life on a smart device, let's say by 2012 to 2013?
Well, the problem that you've got is that battery technology advances very slowly, but the compute requirements of these devices is increasing at a much higher rate. So in terms of battery life, I mean, today getting a day out of your smartphone is pretty good. I mean, I don't think that's really going to change enormously as we go forwards. I think what we can hope for is similar types of battery life, maybe a doubling of that, but with an awful lot more compute performance, more video, more graphics, bigger screens, more higher resolution screens, higher performance processors behind them, enabling all these applications. And I think we're really only in the infancy of that to see what people can do with all of this compute power running off a small battery.
Thanks very much.
Thank you.